yesterday. If you have it out, that's good. If not, you'll be fine. This is where we stopped yesterday. And really what the main thing is this here, when we add or subtract these complex numbers, because a complex number comes in the form of a plus bi, where a is the real number and bi is the imaginary. Real. And there is a theorem, I meant to look it up after first hour, but there is a theorem that states that any number can be written as a complex number. Any and all numbers can be written as a complex number. So give me a number that you think possibly wouldn't work. 0 and 7. Well, they don't have an imaginary part, do they? Is there a way that we can make it have an imaginary part? We can always add 0i, because that's not really adding anything. It just changes it. It makes it into a complex number. So there is a theorem that states that any number, any real number, can be written in complex form, just by this here. But that's not really too important for us or what we're going to cover in here. But mainly what we're looking at is this here. One way we can think about doing this here with addition and subtraction and multiplication, and we're going to get to division, is really I acts almost like a variable. So when we worked with stuff like here, if I had 7 minus 6x minus 3 minus 6x, it's going to work almost the same like this here. They're almost going to work very similar to this. The only difference between how I works, and variables is that we cannot have I squared. We cannot have I to a power. That's the only real difference. Everything else works very similarly. So when we subtract, we're going to subtract like terms, but the signs inside these parentheses are going to change because we're subtracting it. 7 minus 6i is not going to change, but our 3 is going to now be negative, and the 6 is negative, so it's going to become positive because we're subtracting negative 6i. A negative and negative would make a positive. Most of the time, where I see errors or kind of mistakes show up is in this here, because when we subtract and making sure the signs are correct. Well, our like terms are 7 and negative 3. Negative 6i and 6i. Well, we have 7 minus 3 and negative 6i plus 6i. What is 7 minus 3? 4? Yes. And what is negative 6i plus 6i? 0. Those cancel out. So the answer to this is 4. It's just 4. That's our answer. Questions on this here? I think most of you do have your graphing calculators here. Yes? If you don't, that's fine. For those of you who do, try typing that in. Type it straight into the graphing calculator. So I is second decimal. Second decimal. I'm going to pull the graphing calculator that I have on the computer up. It'll take a minute for it to load. So parentheses, I would include the parentheses. I would include everything. Because again, we need the parentheses for this negative, because when we subtract, it applies to both of the terms inside. We need it for that. So I'd type it in just like it is there. And I believe you should get 4. As long as we did all the math right. Okay. So we have this here. Quick. So we had 7 minus 3, 6i minus 3 minus 6i. And it tells you that the answer is 4. So what that means for us is that the calculator here will add and subtract complex numbers for us. Not that I don't think adding and subtracting these complex numbers was too over-the-top complicated. Or just combining like terms, either addition or subtraction. Yes? And that's all we would need to do for this here. Okay, I don't know where that went. And it doesn't matter what they are. We could do any of these here, and the calculator will do them, or we can do them by hand, either one. So do we kind of feel good with addition and subtraction, especially knowing the calculator can do it for us? Yes? Let's look at multiplication. When we multiply, we're really just using the distributive property. So when we have one term, we're multiplying through this one here by 4i. Well, 4i times negative 6, well, 4 times negative 6 would be negative 24i. Well, negative 4i times I, or 4i times I is going to be plus 4i squared. Because I times I will give us I squared. And we have our 4 times 1. Now looking at this here, everything is fine except for the I squared. Because we cannot have a power or an I to any power greater than 1. We cannot have an exponent with it. Now what is I squared? I squared is negative 1. Out of most of these for powers of I wouldn't worry about memorizing what I cubed is or I to the 4th or any other power. But the 2, especially for this next chapter and a good bit going on forward, I squared and I are the 2 that I would really know. So I squared would be one of the ones I would know kind of by memory or kind of seeing it, because it's going to be one of the ones that will show up most often if we have I to any power. I squared is going to be one of the ones that shows up. And I squared is just negative 1. Well, negative 1 times 4 would be negative 4. Yes? And the way that we're really going to want to write this is negative 4 minus 24i. We want the real part to go first. We want the real part to go first. Whatever the number without I normally goes first, then the number with I goes second. That's it there. Questions on this here? Not too bad so far. You ready for the next one? So this one here, I'm going to skip that. I'm going to look at this one. 2 terms, 2 and 2. Because the 1 and 2 isn't too bad. We're going to look at 2 and 2, and then we're going to make these even easier. So to do this here, we're going to distribute all the way across. 9 times negative 4. We're going to distribute. Would be negative 36. 9 times 7i is going to be plus 9 times 7 is 63i. We're finished with the first one. Then we do the same thing with negative 2. Well, negative 2i times negative 4. A negative and negative will make a. And negative 2i times 7i is going to be negative 14i squared. Any questions on this here? So this is very similar to when we did polynomials multiplying through. The same thing? Yeah. Combine like terms? Well, there are no like terms with 36. Everything else has I, yes? Well, these two are like terms. Let's see here, make sure. Okay, yeah, that's positive. 63i plus 8i is going to be 71i minus 14. Well, I can't leave it as I squared, can I? But what is I squared? Any questions on any of this here? Well, negative 14 times negative 1, a negative and negative would make a. So really I have 36 plus 14 plus 71i, yes? I do now have like terms with that. Negative 36 plus 14 would give us negative 22 plus 71i. All right, my highlighter. For those of you who have your graphing calculator, type the starting problem in. So if you don't have your note sheet, it's about to disappear because I'm going to pull the calculator up. Yes. So it'll do it for us. It'll give us negative 22 plus 71i. And for this here, in this class, I will let you, you're going to get to use those calculators on the test. Because you're going to be available to use them. It's good to know this, especially if you take college algebra and they don't allow you to use a calculator or you don't have these anymore. It's good to see how to do it. But for our case in point, the graphing calculators will do this for us. So any questions on this here? So what we've seen so far is, well, with addition, subtraction, and multiplication, the graphing calculator will do it for us. It's kind of nice, isn't it? So we have that there. Now, so the note sheet that y'all do have, that everybody got for today, that's what we're going to start looking at now. Because I feel like with, especially knowing that the graphing calculator will do it for us, we're good with those, yes? Now, the conjugate root theorem. This theorem here states that if a polynomial or quadratic has a root of a plus bi, then a minus bi is also a solution to this. So the conjugate theorem is saying if a plus bi is true, then a minus bi is true. Or vice versa. But what's really changing between these two here? The sign in front of what? The A term, the B term? Well, from one to the other, huh? The B term, the sign in front of I is the one that changes to get the conjugate. And there's something special with these two, and I'll show you this here in a minute. But this here is key, especially for when we're dealing with I, these imaginary terms, these imaginary numbers. We need the conjugate. The conjugate's always going to work. And especially when we start solving these, you will not have one of these complex numbers without its conjugate. They always come in pairs. Imaginary solutions always come in pairs. It also works out that radical solutions, rational solutions with square roots, also come in pairs, like this here. They also have conjugates. So, looking at this first one here, 7 minus I, what would its conjugate be? Well, we'll have 7 and I. But what's going to change? V is going to be positive, because if one of them 7 minus I, its conjugate is 7 plus I. Let's look at the other one. Negative 5 minus 5i. Well, its conjugate would be negative 5, what? Plus 5i. So conjugates aren't too bad. Now, you can do the rest of them, but I want you to look at this here. I'm going to multiply these two conjugates together, 7 minus I and 7 plus I. And something special is going to happen when we do this. Well, 7 times 7 is 49. 7 times I is plus 7i. Negative I times 7 is minus 7i. And negative I times I is negative I squared. There's no like terms with 49. We do have two like terms here. What happens to those two terms? What is 7i minus 7i? 0, yes? These cancel out. Minus, well, I squared is what? So I really have 49 plus 1, which is, what happened when I multiplied the two together? What am I missing? I don't have I anymore, do I? That's what makes these special. That's what makes these special, because I now have a number without I when they are multiplied together. And probably you're not even thinking about this, but when we talk about solutions or quadratics, these quadratics will have solutions with I. But if we come across an equation that had I in it anywhere, you'll know, right? This is why these conjugate theorems work, why they go in pairs. Because when we multiply them together, we get a number, yes? When we multiply them together, we get a number. That's why we don't see I in a quadratic equation, is because when we get the solutions, it's pulling them apart. It's pulling them apart. Questions on this here, finding these conjugates. We kind of like these conjugates, they're easy. 2 plus 4i would be, negative 2 plus 4i would be negative 2. How about this one? We're good with these here? I think 7 and 8, yep. We'll make number 9. Find the conjugate of negative 36i. What would it be? 36, what? It'd just be 36i. Because really what we're saying is that I have 0 minus 36i, which is conjugate would be 0 plus 36i. We just don't have a real part to it. So even though there's not a real number there, we still switch it. What is the complex conjugate of 72? Because what are we changing? We're changing the sign in front of the term with I, the B term, yes? So here it's really saying we have plus 0i. Here we're now saying we have minus 0i. Does that change the value of 72? No. And that's one of the ones they'll normally, especially on, they'll throw in every now and then to see, hey, are you paying attention? So it doesn't change the value of 72. It's only changing the value of I. Yes, sir. For conjugates? No, we'll have to do those by ourselves. We have to do those by hand. Now, the reason we do that is dealing with division, because we cannot have an I in the bottom of a fraction. We cannot have an I in the bottom of a fraction. If you want to go on and try plugging this in, go on and do it. I'll give you a second to type that in. I have a feeling most every single one of those calculators said domain error, invalid, something error, if you got it typed in. Okay, so let's do this one by hand. Now, what we want to have happen is we don't want any I terms left in the denominator. Yes? Well, we saw, I did an example already, where if we multiply, so 1 minus 2i by its conjugate, the I terms will eliminate out. Yes? So what we do to simplify this here is I multiply the denominator by its conjugate. So we do it on top and bottom. So we're going to multiply the top and bottom by 1 plus 2i. Well, really, what is 1 plus 2i divided by 1 plus 2i? Anything divided by itself is what? 1. So really, what am I multiplying this thing by? 1. It's just a fancy 1. Because when we do this, the denominator should and will have no I terms left over. It should eliminate all the I terms. And we'll see that. On top, we'll do 4 times 1, which is 4. 4 times 2i is going to be plus 8i. 3i times 1 is going to be plus 3i. And 3i times 2i is going to be plus 6i squared. So are we good with everything so far? We just multiplied across the top, yes? So let's do the denominator. Well, 1 times 1 will give us 1. 1 times 2i is going to be plus 2i. Negative 2i times 1 is going to be negative 2i. And negative 2i times positive 2i is going to be negative 4i squared. Any questions on any of this here so far? We good with all this here so far? Yes? So, on top we can combine some like terms. Well, 4 isn't going to combine with anything yet. 8i plus 3i is going to be plus 11i. I squared is negative 1. So we still have some I terms in the numerator, and that's fine. It's perfectly fine. The denominator, well, 2i minus 2i, those are going to cancel out. So I have 1. Minus 4 times negative 1, because I squared is negative 1. Do I have any I terms left in the bottom of the fraction? No. 6 times negative 1 would be negative 6 over, because negative 4 times negative 1 would be positive 5. Are we good with everything right here? Because I did move the 6 over. Because 6 times negative 1 would be negative 6, and I just moved it so it's next to the like terms. The like terms are next to each other. Four minus 6 is negative 2. Plus 11i over 5. Any questions on how we got to this point here? Now we can split this up into 2 fractions and say negative 2 fifths plus 11 fifths I. Both of these are the correct answer. They'll sometimes split it up if one of them is able to reduce differently than the other. So they'll write them in either one of these forms. And negative 2 plus 11i over 5 we did all of this here for our any questions on this here? Do we get kind of what we're doing with this here? We understand how this works? Yes? So y'all tried typing in the calculator, didn't work, correct? I think it should. Let's try typing it in. I'm going to type it in. Parentheses 4 plus 3 I divided by 1 is. So y'all typed it in like this here, yes? The ones that tried it? Yeah, no, it doesn't work in the fraction. But if we do it by division instead, it'll do it. Don't know why. I have no idea why. When we put it as a fraction, one over the other, it throws it out completely. However, I don't think I have the calculators. Oh, someone's borrowing it. The TI-84 plus CE, the color edition, will do it in that fraction form. It'll actually take it as a fraction, where we do alpha y equals. These here won't. So instead of writing it as a fraction in alpha y equals, we'll write it as division. Now, it might not always give you nice decimal numbers, okay? So there's one other step. I will do math. The first one is FRAC. You don't remember what that's short for? Fraction. We'll hit enter. A and S arrow fraction is saying take the previous answer that I got and turn it into a fraction. If we hit enter, is that what we got? Yeah. Very good. So you all have the note sheet. So first thing we want to do is we want to type it in. I'll write it. So we want to type it in the crafting calculator. I'm going to redo this. I'm going to